Hi everyone, I hope everybody's doing well. So today what we're going to be doing is running some metal powders. So customer asked me, should we run it wet? Should we run it suspended dry? Will I see a difference? In theory, you shouldn't see a difference. So what we're going to do is we're going to run it wet, then we're going to run it dry, and we're going to check. So as you all know, the Raptor has several ways of suspending particles. We can suspend it with an external sample vessel that we have, and you have all the tubing to go in and out. You could also attach it online. We have the dry powder system, which we're going to be running, but you can also run it really quickly manually as well. So, and that's what we're going to do. So to run it manually, all I did is I put some of this tungsten metal powder into 2 syringes into our disposable portable sample cell, and we're just going to put it into the Raptor. And what I'm going to do is I'm just going to start a brand new run. I'll just do an increment on this run, and I'll just do a quick start, and then I could just start moving the sample around, and you'll start seeing that you'll get a lot of number weighted information, but also obviously we know that we can look at volume weighted information. So I think right now it's set up to run for 90 seconds, but right now we already ran 19,000, 21,000 particles, 24,000 particles, 27,000 particles, 29,000 particles. So I think, we got some good representative sampling, especially since our mode and mean are not changing. So I'll go ahead and I'll stop it, and we'll just finish up. So when we finish, we go to our dashboard and we get to our customized dashboard. And again, we have a number weighted distribution and a volume weighted distribution. It's doing a lot of work because there's 92,000 particles that we ran here in a few seconds. And what we're going to be, the dashboard that I put in was to, my customized dashboard is to have the particle thumbnails as well as the classifications. So here we go. So let's move this out of the way. So we can go through and go through 92,000 thumbnails, which is entertaining, but again, that's not where the real value is. So what I did here is I ran, obviously some of these particles are very agglomerated, not good. But I came up with a classification here where we have round, not round, large, and small. So we can actually say, okay, show me just the large particles, show me those thumbnails, and we'll see that the large ones were 7.79% of the distribution. And the large ones are some agglomerates and some really long, strange ones. These are 100 microns, pretty big. We can go through all those 7,199. We can go and look at let's look at the round particles. So let's look at those round particles. So we select round. This represents 40.12% of the distribution. Let's go ahead and look at those thumbnails. It may take a little bit here because it's going through 37,000 thumbnails. There we go. And these are the round particles, right? So obviously all very round. Let's look at the not round. This is 12% of the distribution. What is this? 11,317 particles. And yes, definitely those are not round. Definitely not round. So again, not just getting thumbnail images, that's not the benefit of a shape analyzer. The benefit of a shape analyzer is the ability to classify and look for percentages and concentrations of specific subpopulations in your sample. So that's why you would get such an instrument. So we ran a wet sample. Let's run a dry sample. So to run a dry sample, no, we ran it wet again manually. Again, you could have done it any other way with the external vessel, but I just wanted to show you quickly how we do these swap outs. So here it is wet. To do it dry, pull out the sample cell. We're going to go ahead and put in our dry sample cell. I'm going to put in our dry powder feeder right on top, and we already have some dry powder in there. So what I'm going to do is I am now going to just go back to sample information, and I'm going to copy the name. I'll do new sample, and I'll paste the name, but I'm going to add the word dry. And then what we'll do at this point is we can start the vibratory feeder and just do a quick start. So once we have a variable, a rate that we're comfortable with, look at the concentration. We want to make sure we have the right, not overly concentrated by looking at the particles per ml, and we'll let it run. So I'll come right back when we get to the end of our run. So see some agglomerates here. So this is, I did suspect a little bit of this. I did suspect some larger particles because with a dry suspension, you don't have the dispersing abilities that you would wet. So I did expect some of these. Didn't see that many, but there are some that are kind of agglomerated that I think if we would have suspended. But again, you can go in and look at just the specific thumbnails that you're interested in. Very interesting information, and again, shape very important when it comes to additive manufacturing materials. Getting good representative sampling. In this case, we ran 92,455 particles. We have a specific concentration that we were going after. We were running about 531 particles per image, and we got some good data. So we ran it pretty quick. Anyways, if there's any questions, let me know. I hope this helps, and thank you for looking. Have a great day.